Module 6, Networking for CCTV and Smart Automation Systems. Module Overview. In today's digital-driven world, networking forms the backbone of modern CCTV systems and smart automation infrastructures. Unlike the older analog systems that relied on coaxial cables and direct DVR connections, the current generation of CCTV and automation setups heavily depend on IP networking to achieve scalability, flexibility, and remote accessibility. Networking for CCTV and smart automation involves not only basic LAN/WAN knowledge, but also understanding protocols, IP addressing, bandwidth management, switches, routers, firewalls, and cloud integration. This module will deeply explore the principles, components, configurations, troubleshooting, and professional practices required for ensuring reliable, secure, and efficient networks that support video surveillance and automation technologies. Section 1. Fundamentals of networking in CCTV and smart automation. Types of networks. LAN, local area network, limited to a building or site used for connecting CCTV cameras. NVRS, automation controllers, and IoT devices. WAN, wide area network, extends connectivity beyond a site, often through ISPs, enabling remote monitoring and smart home controls via the internet. WLAN, wireless local area network, uses Wi-Fi for camera and device communication, suitable for flexibility but prone to interference if poorly managed. Networking topologies. Star topology. Each device connects to a central switch/router, ideal for CCTV as it isolates faults. Bus topology. Not common today but still seen in legacy systems. Mesh topology. Used in smart automation and IoT for redundancy and resilience. If one node fails, traffic reroutes. Protocols and standards. TCP/IP. Backbone of modern communication. ONVIF, Open Network Video Interface Forum, ensures interoperability between different CCTV devices and brands. DHCP versus static IP, dynamic addressing for flexibility versus static for stable CCTV configurations. PoE, Power over Ethernet, supplies both data and power to cameras using a single cable. Section 2. Key networking components in CCTV and automation switches. Managed versus unmanaged. Managed switches allow VLANs, QoS, quality of service, and advanced configurations to separate CCTV traffic from automation traffic. Unmanaged switches are plug-and-play, cheaper but lack control. Routers and gateways connects LAN to WAN for remote access. Enables port forwarding or VPN setups for secure access. Network video recorders, NVRS, store and process video streams from IP cameras. Require correct bandwidth allocation and IP configuration. Firewalls and security systems protect CCTV and smart devices from cyber threats. Must be configured with strong passwords, firmware updates, and secure ports. Section 3. Bandwidth, storage, and latency considerations. Bandwidth calculation for CCTV. Formula. Resolution times. Frame rate times, compression times. Number of cameras. Example 10 IP cameras at 1080p, H.265 compression. 15 frames per second require careful bandwidth allocation. Storage management. CCTV systems use NVRS, NAS, network-attached storage, or cloud storage. Retention policies vary, 7 days, 30 days, or longer for compliance. Latency issues in smart automation. Delays in network cause poor responsiveness of smart devices. Prioritize CCTV and automation traffic via QoS quality of service. Section 4. Networking configurations. IP addressing. Static IPs recommended for cameras/NVRS. Private versus public IPS for local versus remote access. Port forwarding versus VPN. Port forwarding exposes systems but is easy to set up. VPN ensures secure access but requires more expertise. Cloud connectivity. Platforms like P2P cloud services allow plug-and-play remote access without advanced configurations. Section 5. Cybersecurity and CCTV and automation networks risks. Camera hacking, device hijacking, data breaches. Solutions. Use strong credentials and avoid default usernames and passwords. Implement firmware updates regularly. Segregate CCTV and automation networks from corporate or home office networks. Section 6. Advanced networking for smart automation. IoT integration. Smart lights, locks, HVAC, and sensors all require reliable networking. Zigbee, Z-Wave, and Wi-Fi play key roles alongside traditional IP networks. Network redundancy. Use dual ISPs, failover systems, and mesh networks to prevent downtime. Cloud versus local processing, edge computing. Edge devices process data locally, reducing reliance on internet speed. Example, smart AI CCTV cameras analyzing motion without cloud dependency. Section 7. Troubleshooting and professional best practices. Common issues, IP conflicts, poor video quality due to insufficient bandwidth, latency and dropped connections in automation systems. Best practices. Document all IP addresses and network maps. Regularly test and audit systems. Use VLANs to isolate CCTV from automation to prevent interference.